Hey everyone, welcome back to the channel. Today, we're diving into the fundamentals of mechanical engineering. The essential basics you need to understand if you're starting in this exciting field. Basic mechanical concepts, welcome. Today, let's quickly break down the core mechanical concepts. Force, torque, and energy. Force is a push or pull that causes an object to move or change direction, measured in newtons. Torque. Think of it as a twisting force that makes a wrench turn a bolt. Energy is the ability to do work like lifting, moving, or heating something. Energy comes in many forms: kinetic, potential, and thermal. All machines, from engines to elevators, rely on mastering these basics. Understanding these simple ideas? That's your first step to mastering engineering. Introduction to thermodynamics. Ever wonder how engines and refrigerators work? It's all about thermodynamics. Thermodynamics studies how heat, work, and energy move and change. There are four main laws. Zeroth law. If two systems are each in thermal equilibrium with a third system, they're in equilibrium with each other. First law. Energy can't be created or destroyed, only transferred. Second law. Heat naturally flows from hot to cold. Third law. At absolute zero, everything stops moving. Thermodynamics is the hidden power behind almost every machine. Let's explore more in the next video. Basics of fluid mechanics: water, air, oil. Fluids are everywhere. But how do they move? Let's dive into fluid mechanics. Fluid mechanics studies how liquids and gases behave. Two key ideas: viscosity, how thick or sticky a fluid is; pressure, the force fluids exert over an area. From planes flying in the sky to blood flowing in your veins, fluid mechanics explains it all. Master fluids, and you master a huge part of the real world. More coming soon. Strength of materials explained. How do we make sure bridges, buildings, and machines don't collapse? Strength of materials holds the answer. This branch studies how materials react to forces: tension, compression, bending, and twisting. We measure stress, force per unit area, and strain, deformation, to make sure materials are strong enough. Different materials behave differently. Steel stretches, concrete cracks, rubber bands. Choose the right material, and your design lasts a lifetime. Heat transfer basics: from boiling water to cooling engines. Heat transfer is everywhere. Let's understand how. Heat moves in three ways. Conduction. Heat transfers through solids, like a hot pan handle. Convection. Heat moves through fluids, like boiling water. Radiation. Heat moves through space, like sunlight warming your skin. Engineers use these methods to design everything from fridges to rockets. Heat moves constantly, and controlling it is pure engineering magic. Introduction to manufacturing processes. How are everyday products made? Welcome to the world of manufacturing processes. Manufacturing turns raw materials into finished goods. Key processes include casting, pouring molten material into molds; machining, cutting away material; welding, joining pieces together; 3D printing, building parts layer by layer. Everything around you are manufactured. Understanding how it's made unlocks endless possibilities. Pumping machinery. Need to move water, oil, or gas? You'll need a pump. Let's see how pumping machinery works. Pumps move fluids by mechanical action. There are two main types. Centrifugal pumps use spinning impellers to push fluid outward. Positive displacement pumps trap fluid and force it through the system. Pumps are crucial in everything from cars to water supply systems. Without pumps, modern life would come to a stop. Stay tuned for more insights. 8. Heat exchangers. Ever wondered how your car's radiator cools the engine? That's the job of a heat exchanger. Heat exchangers transfer heat between two fluids without mixing them. Common types include shell and tube. Fluids flow inside and outside the tubes. Plate exchangers. Thin plates create paths for fluid to flow. They're critical in HVAC systems, power plants, and even refrigerators. Smart heat management is key to efficient machines. Learn it, and you're ahead. Material science. What makes metal tough, a plastic flexible, or a glass brittle? Welcome to material science. Material science studies the structure and properties of materials: metals, polymers, ceramics, and composites. It answers: why does steel rust? Why does rubber stretch? Why is carbon fiber so strong and light? Choosing the right material can make or break your project. Let's keep learning. Machine design. Every machine you see started with one question. How do we design it? Machine design blends mechanics, materials, and creativity. It involves defining the problem, analyzing forces and motions, selecting materials, creating safe, efficient, and cost-effective solutions. Design smart, and you build the future. 11. Electromechanical devices. What do elevators, washing machines, and robots have in common? Electromechanical devices. Electromechanical systems combine electrical and mechanical parts. Motors, sensors, switches, and mechanical components work together to perform complex tasks automatically. Think about an electric motor drives the gears, a sensor detecting position. Mastering electromechanical systems means opening doors to robotics, automation, and innovation. In the upcoming videos, we'll take a deeper look into each of the 11 fundamental topics we introduced today, including force, torque, energy, thermodynamics, fluid mechanics, strength of materials, heat transfer, and key manufacturing processes. Each topic will be explained in detail with real-world examples, simple diagrams, and practical applications to help you build a strong foundation in mechanical engineering. If you're passionate about learning and growing your engineering skills, make sure to subscribe to the channel. Like this video if you found it helpful, and share it with friends who are also interested in engineering. Your support helps us create more valuable content, and together, we'll engineer a great future.